Hello, Math 8 students. This is Parallel Lines and Angle Relations practice. Before we begin on our practice, I want to make sure that we take some additional notes to help prepare us for all of those angle relationships we're going to be seeing. We are going to start with an X. Draw two intersecting lines. I'm not going to be measuring any angles here. I want to focus just on relationships. So, what is the relationship between this angle that I just highlighted and this angle here that I just highlighted? There is a relationship. Looking for both the name and something that you know about them. Weston? Okay, great use of the vocabulary. One of them is an obtuse angle, one of them is an acute angle. Great. But I'm looking for the pair of them together. What do we know about them? Cal? Okay, so let's start with what we know. We know that they are going to add to 180 degrees. And you also figured out the word. That word is supplementary. These are supplementary angles because they add to 180 degrees. We are writing this down. Supplementary angles add to 180 degrees. There's an additional word that we can use to describe these. We may have only used it once or twice. The word is adjacent. Adjacent is just a fancy word meaning right next to. Point to somebody who is adjacent to you. Okay, it should have been someone who is sitting right next to you. That would be adjacent. Focusing mostly on the supplementary, they will add to 180 degrees. Okay, I'm going to move the highlights around. What if I wanted to focus on still this highlighted one and now that angle? What is that relationship between those two angles? Michael? Weston, help him out. They're vertical angles. What do we know about vertical angles? What do we know about vertical angles, Ariel? Yeah, they're the same measurement. So vertical angles are congruent. Vertical angles are congruent. So that means whatever this in, notice that it is an obtuse angle. The one directly across from it is also the same. It is also an obtuse angle. Not just any old obtuse angle though, it's the same as this one. Okay, vertical angles are congruent. Adjacent angles are supplementary. They add to 180 degrees. That's the first relationship that I want you to know. Okay. Moving on, new diagram. I'll keep that there. But I'm going to add a new diagram. This time in the diagram, I want us to draw parallel lines. When I draw parallel lines, please don't make them that close together. That's going to be way too hard to do all the things that we want to do. Please make sure you spread them apart so that we can have enough space to write the things that we need to write down. So these lines are parallel lines. And I'm also going to draw a line that goes through them or intersects them. What is that line called? We have talked about this one. There's a special name for it. Aaliyah. Yes, this is a transversal line. Transversal line, and a transversal line simply means a line that intersects others. So Mathematicians will say about this diagram that we have parallel lines cut by a transversal. And when we have parallel lines cut by a transversal, it gives us certain relationships between all of the angles. So I'm going to continue using colors to highlight these different properties, and I'm going to continue to highlight angles to draw your attention to those certain angles. Okay, are you ready? Pop quiz. What is the relationship between this angle and this angle? Seth. Yeah, it's vertical angles. Same one that I already showed you up above. I'm just going to show you the same relationship on a diagram that has parallel lines. Okay, this is vertical angles. And finish the sentence. Vertical angles are, Weston, congruent. So since they're congruent, I'm going to replace these highlights with the same color. This angle here is the same as this angle here. So I have a question for you. Do I need to know that these lines are parallel for those vertical lines to be congruent? What if I didn't even have that line? What if it was just like that? Would I still have vertical angles? Yeah. So this is one of those things where knowing that these are parallel lines, that's just kind of a bonus. It's just kind of an extra thing. All right, now I'm going to move the highlights again. And I want to focus on this highlighted angle and this highlighted angle. What's the relationship here? There should be more hands, so talk your tables. What's the relationship? What is that relationship, Caleb? Great. Supplementary angles that add up to 180 degrees. Basically, no different than what we saw up here. What's the new word that we can also use because they are right next to each other, Cadence? Adjacent. So these angles are adjacent and supplementary. And again, supplementary simply means that they add to 180 degrees. So adjacent and supplementary, they add to 180 degrees. I'm not going to mark them the way that I marked these red vertical angles because are they the same angle? No, one's an acute angle, one's an obtuse angle, so clearly they're not the same angle. But the pair of them together will add to 180 degrees. Okay, new relationship. Let's see what you know. Moving the highlights around. I want to know this angle here that's highlighted and this angle here that's highlighted. Check in with your tables. What's that relationship? What is the relationship between these two highlighted angles? Mappa. These are corresponding angles. I can take this angle and literally translate it straight up and it will land on the other one. So this angle here will translate up here, making it corresponding angles. Finish the statement. Corresponding angles are congruent because a great clue is this is an obtuse angle and I can pick it up and move it and it still is an obtuse angle. So that's a big clue that they're probably congruent. But since I can translate them and I can get from one to the other with rigid transformations, that confirms that corresponding angles are congruent. Congruent. So I am going to color this one in the same color that I color this one to show that they are congruent. They will have the same measure. There are other corresponding angles in the diagram. Who thinks that they can find another pair of corresponding angles? Great. Philip, go and point to one. Yes? Show me again. This one that's already colored green? And this one? Those are not corresponding. There is a relationship, but they are not corresponding because I can't pick up this angle and translate it and have it land perfectly there. You'd have to do something else. So it's not corresponding. There's another pair of corresponding though. Bridger, can you go point? Yes. Okay. So don't mark your diagram yet. I just want to use color to highlight this one and this one. Don't mark it. Just showing that this one and this one are the same. We're talking about orange and orange because I can just translate it up along that transversal and have it land right there. Great. One more. There's more, but let's just focus on one more. Michael, go and show me. Okay, this one, which is already colored in red, I can translate it and have it land right here, and that one is also corresponding. So just because I marked this one green one doesn't mean it's the only one. There are lots of corresponding angles. And again, I'm just going to throw that away. I don't want to fill up the diagram with too many things. There is another relationship that I want to look at now, and that is the one that, was it Philip? The one that Philip pointed out. So let's look at this green angle, and let's look at this one. What is the relationship here between the blue squiggle angle and the blue squiggle angle? Turn and talk with your neighbor if you're not ready to answer yet. Turn and talk with your neighbor. Ready, set, go. All right, what is the name of that relationship? Ariel. AIA, which stands for? Great. Alternate interior angles. Alternate because this one is on the left-hand side of the transversal, and this one is on the alternate side, the right-hand side. And interior because they are both on the inside of those parallel lines. So this blue relationship here is alternate interior angles. We learned the alternate interior angles were congruent because we learned that with a rotation. We could rotate it around the midpoint and have it land on itself, so alternate interior angles are congruent. Yes, Weston? Okay, and the last relationship to focus on is this orange one and this orange one. What do you think that one's going to be? Oh, I'm trying to get rid of the highlights and I can't quite get it. What do you think, Michael? Great. Alternate exterior, very similar to AIA, alternate interior angles, but these ones are on the outside or the exterior. They're still on alternate sides though. This one is on the right-hand side and this one is on the left-hand side, so they're on alternate sides or different sides in the transversal, but they are on the outside. So that one would be alternate exterior angles. And alternate exterior angles are congruent. Okay, with that in mind, we are now ready to begin our parallel lines and angle relations practice. To get started on the first set of problems, I ask you to identify each pair of angles as corresponding: alternate interior, alternate exterior, vertical, or adjacent. But please add this extra piece, adjacent and supplementary, because if they are adjacent, if they are right next to each other in these diagrams, they are also going to be supplementary, and the supplementary is the part that's the most important to me. I want you to recognize when they add to 180 degrees. So here's how we look at these diagrams. In problem number 1, I have parallel lines that are cut by a transversal, and I have this angle is marked, so that's angle X, and this angle is marked, that's angle Y. I'm not asking you to find the measure of the angles or anything like that. I just want to know, how are those two angles related? The two angles that are highlighted, how are they related? I asked that question before when we were building our last diagram. MAPA. Supplementary. So these are supplementary angles. They form a straight angle, a straight line. So these are, I'm going to write down not just supplementary, I want us to practice the new word as well. These are adjacent and supplementary. Let's try another one. Let's try number 2. Again, they're, instead of highlighted, they're marked by saying, here's one I want you to pay attention to, here's the other one. I like adding the highlights. What is that relationship there? Everyone ready to say it on the count of 3? 1, 2, 3, go. Great, vertical angles. Yes, these are vertical angles. You get the idea now, right? Let's look at 3. Here is the first angle I'm looking at. Here is the second angle. Really focus on that relationship. Where are they in relation to each other? Where are they in relation to the whole diagram? Are you ready to state your answer? Give you 5 more seconds, and then we're going to do a countdown to call it out. Okay, be ready to say it out loud in 3, 2, 1. Yep, AIA. You guys were lazy. You didn't say the whole name, but you were correct. This is alternate interior angles. I'm okay if you say AIA. As long as, do me a favor, and come up here and make sure that we are making note to ourselves, alternate interior, we're going to write down AIA. We're going to be lazy on this one too, aren't we? On alternate exterior angles, we're going to write AEA. Okay. AIA, again, that means alternate interior angles. All right, number 4, start looking at the relationship between this angle that's down here and this angle that's down here. In 5 seconds, we'll do a countdown. Okay, 3, 2, 1. Fantastic. These are corresponding angles. Okay. That is how we're going to work through the problems in this section. Let's move on to the next section here. In this next section, we don't have parallel lines at all. We don't have intersecting lines forming an X or anything like that. We just have triangles. So turn and tell your neighbor something that you know about triangles. What can we do with these diagrams? Turn and tell your neighbor something you know about triangles. Now raise your hand to tell me what is something that you know about triangles. Ozzy. They all add up to 180 degrees. Also pointy, but the pointiness doesn't help the part where we have to find the measure of the angles. True statement, just an unhelpful one. So this angle is marked as 50 degrees. This angle is marked, what does that mark mean? 90 degrees. This angle is the one that is indicated that I'm trying to find the measure of. So, do you guys trust me? Have I ever led you astray? Eyes on the screen. I'm setting you up for success for a future problem. Okay. I know what you want to do is you just want to go straight to your calculator and type in 180 minus 50 minus 90. Don't do that. Trust me. I'm going to help you out. set up an equation. Okay, we have a 50-degree angle, that's right here. We have a 90-degree angle, that's right here. And 50 degrees plus 90 degrees plus mystery. I don't like adding question marks, so you know what I'm going to do instead? I'm going to call it x. Okay, so 50 plus 90 plus mystery angle x. What happens when I add up the three angles of a triangle? They add to 180 degrees. Tying this into our equations unit that we did before our transformations unit, we should probably combine our like terms before I try and solve anything. What's 50 plus 90? That's 140. But don't forget, we still have our variable, 140, plus our mystery angle x is equal to 180. And we can solve this equation. Since x is being added by 140, I can get rid of that by subtracting 140, but I have to balance it, and whatever I do to one side, I do to the other side. And that is how I get x is equal to 180 minus 140 is equal to 40. So what is the measure of our mystery angle? 40 degrees. Okay, I just want, on these other ones, I don't care if you do them another way, but I want you to understand I'm going to reuse this process for a future problem. Instead of just typing things into the calculator and going straight to subtracting, I want you to understand why we're doing that. All right, and that's what we're going to do in those remaining problems. We're going to move on past those for now. Let's take a look at the next set. Getting slightly more complicated now. It says, solve for x. Where's x? It's right here. There's no way I would be able to solve for x just by going straight into the calculator and typing things in without having first a foundation. And I don't need to be worried because I remember that when I add this red angle and this blue angle and this green angle, because those are the three angles of a triangle, what am I going to get? 180 degrees. So let's write an equation that says that. When I take 55 and I add 70 and I add the green angle, x plus 65, I get 180 degrees. And just like before, I have like terms to combine. I have 55 and 70, and I have 65 that I'm going to combine. And when I get 55 plus 70 plus 65, give you a second, probably need to type that into your calculator. 55 plus 70 plus 65, yes, 190, very good. 190, don't forget we still have our x, right? So 190 plus the x is still equal to 180. Is x alone yet? No, so let's solve for x. That means x plus 190, and I will add 190 by subtracting 190. Whatever I do to one side, I do it to the other side. That zeroes out, and I have x, which is equal to 180 minus 190, and I get what, Weston? No, you don't. Be careful. 180 minus 190 is negative 10, exactly. X is equal to negative 10. So, have I answered the question? Yeah, I said solve for x. Do I know what x is? Yeah. Now, it's not saying that the angle is negative 10, right? It's saying that the x is negative 10. So if I wanted to know what the angle measure was, since x is negative 10 and x is added to 65, I'm going to have negative 10 plus 65, which is equal to 55 degrees. So if it were asking what's the measure of the angle, I could still answer that question too. It's 55 degrees. So you can practice that with number 14, but now we're going to increase the challenge level again. Find the measure of angle A. But again, it's not that it's any more challenging, it's really truly just I've added some extra steps. Here's angle A. Angle A is x plus 44, so that doesn't really help. But I know that when I add x plus 44 to the other angles of the triangle, 70, and x plus 84, I'm going to get 180. So I'm setting up an equation and taking the time to simplify before solving it. I'm going to combine like terms. So this time I have my constants, 44 plus 70 plus 84, but I also have my x's, an x and a second x. X and x combine to be 2x. And 44 plus 70 plus 84. I'll need some help on that one. You already have it done, Mappa? 198. And now that is equal to 180. We've been through this solving equations unit, so this is easy compared to what we used to have to do. We're going to undo adding 198 by subtracting 198. Balance it by doing the same thing to the other side. Zeros out, and I have 2x, which is equal to 180 minus 198. And I get negative 18. Divide each side by 2. And I have x is equal to negative 9. Have I answered the question yet? No. I have x, but the question is asking us to find the measure of angle A. Well, I've done the worst part. X is equal to negative 9, so that is going to just go right in here. X is negative 9. Add that to 44. And that means A, the measure of angle A, is equal to negative 9 plus 44 is equal to 35 degrees. And that's what you'll do for those last couple of problems. Okay, I really like these problems. There is a certain property that we could talk about, but I want to show how we can do these kinds of problems even if I haven't taught you the fancy property. So, look at this diagram and let's see what we know. First of all, I see a triangle, and I know that when I add the angles of a triangle, it's going to be 180. But I have an extra piece of information here. Not only do I have a triangle, do you see how that triangle extends? So what do I have here? I have, Philip, adjacent angles, which are also going to be supplementary. They're going to add to 180 degrees. So knowing that they add to 180 degrees, can you find the measure of this angle on the inside of the triangle? You can probably do it in your head. I don't think you need a calculator for that one. What is it? What is the measure of this angle here on the inside of the triangle? Mappa? 100 degrees. I'm not going to put the degree symbol. That makes it look like 1000. So 100 degrees. And again, when I add this angle and this angle and this angle, I'm going to get 180. So 100 plus 50 plus mystery angle, which I'm going to call x. That is going to be equal to 180. Can you figure out what the x is? Of course you can. Because 100 plus 50 is 150. Plus the mystery angle is equal to 180. You probably don't even need to go through the whole entire solving equations process just trying to make another connection. You can figure out that x is equal to 30 degrees. So I like these diagrams because there are a couple of steps, but we can find the other angle. Why don't you work on number 20 right now with your tables. Work on number 20. I'm going to pause the recording as they work. Close. So this angle itself is not 80 degrees. However, 50 plus 80 here is 180 degrees. But then I'm going to go another step. Because now that I know that these angles add up to 180, I'm going to use that information. Can you figure out what the other side is now? What is it? Mappa? 100. Because 80 plus mystery is 180. That's 100 degrees. All right, and the last set of problems, the last type of problem that you're going to see. Find the measure of each angle indicated. We're going back to the beginning. Hey, wait a second. Don't we know the relationship between this angle here and this one? That's alternate exterior angles. And we know that alternate exterior angles are congruent. So if this one is 71 degrees, then this one is going to be 71 degrees. How do I know that? A, E, A. So now I'm going a step further. Instead of just saying, what is the relationship, I want to know, can you use that relationship to answer the questions? We've had a lot of warm-ups like this, so this is nothing new. This is 101 degrees, and this is vertical angles. So 101 degrees using vertical angles means that our mystery angle is also 101 degrees. You'll just continue using the properties that you already know to find the measures of the angles that are indicated. That is it for this lesson video. Thanks for watching, and we'll see you next time.